So Algebra 2, 6.5, what we're doing today is dividing polynomials, and this wraps up the last section, a little bit of new learning before we quiz in a couple days. Dividing polynomials, there's two types. You could be dividing by a monomial, which means there's one term, and that's what we're going to do here. Or you could be dividing by a polynomial, which means more than one term, that's what's going on over there. So if we're dividing by a monomial, that's something like a 2x. There's no adding, subtracting in there, it's just a single term. And the books, some of them, they're going to maybe write a big long fraction bar to divide and put the 2x on the bottom. Others, they may wrap things up in parentheses and put the 2x after the divide symbol. That's the same thing. Either way, the 2x is called the divisor. This other thing is called the dividend. These two problems are the same. They'll have the same answer. They just look a little different. But what we're going to do with these monomials is something we did a couple days ago. We're just going to divide this into every single term. Or you can imagine just separating this into like 4 fractions. This could be a fraction that can reduce. 12 can divide 2 to get 6. The x's can somewhat cancel. There's 2 more on the top. So we could get 6x squared out of that first part. For this, we can divide 8 by 2 and get 4. There's more x's on the top by 1, so we could go plus 4x. Here, 4 can divide 2 and get 2. The x's completely cancel. All we get is a 2. And for this last piece, if you can't divide ever, just make a fraction. Put 1 on top of 2x. If that would simplify a little bit, simplify like we did the other ones, but if it doesn't, just leave it alone. But that's what we would do for an answer on that. If we're dividing by a monomial, just divide into each thing. If it doesn't go, reduce like perfect. Second problem type's dividing by a polynomial. So they could write these with parentheses and have the division symbol and have more parentheses. It's just going to have adding or subtracting in the parentheses. Polynomial just means it's more than one term. But you're going to do better on these to write this with the old-fashioned 4th grade, whatever grade that is, you learn that division blocks. So the x plus 3 is the divisor, put that out to the front. This other thing, the first one, is called the dividend, put that in the box, and we just look to divide. So let me make up another sort of problem, 4th grade like. To decide what to do, you start off just looking at the leaders. So you don't know your 21 times tables, so you would just think, can 2 go into 1? No. Can 2 go into 19? Yes. 9 times. So that means 21 probably goes into that whole big number 9 times. You're going to do that same thing on these. Just look to the leaders. If you want to do this divided by this, you're thinking in your mind, x squared divided by x is another way we could write this. We'd get a little bit of cancellation going. Top is bigger by x. So x times x is going to make x squared. This divided by this makes this. Just like 19 divided by 2 made 9. That's your first start. Then in the old days, you took 9 times everybody. 9 times 1 is 9. 9 times 2 is 18. But 9 times everybody. We're going to do the same thing here. X times everybody. X times x is x squared. X times 3 is a 3x. And then we go at it. Just like in the old days, you used to subtract to get 9. In the new days, we're going to subtract. Those are going to vanish. 5 minus 3 is 2x. And I'm going to drop the plus 6. Just like if this problem had a 4 at the end, I would drop the 4. And then we go again. We think 2 into 9. 4 times. So I'm thinking this into this. Just look at the leaders. If 2x divides x, think of it this way if you like. 2x divides x. A little bit of cancel. That's going to be a positive 2. 2 times everybody. 2x plus 6. Subtract. There's no remainder. So that's just the answer. If you ever divide and get no remainder, what it means you probably could have done is factor. X plus 3, x plus 2 in this case can replace that. And the x plus 3's could have canceled. That might have been a quicker way to get x plus 2 out of that one. That'll work occasionally. I wouldn't rely on that as a strategy. Most of the homework questions, most of life's division problems have remainders. But if you do get zero remainder, you can factor cancel the check. So let's go again. The process is the same. I'll do two more. For this problem, when I set it up, I left a gap. Anytime there's missing powers, third power, second power, there should usually be a first power before there's a number. If you're short any of the powers in descending order, just leave a gap there in the dividend. In the divisor, it doesn't matter. Okay, this is short the x and the dividend. It doesn't make any difference. Again, divide the leaders. X cubed divides x squared. So if you think about x cubed divides x squared, you think about the canceling that would happen. This x cubed wins by an x. This top multiplies everybody, so x cubed minus x. I'm not going to put the minus x with the x squared because that's unlike. I'm going to put the minus x where I left a gap for all the x's to go, and then I look to subtract. Subtracting these will make that vanish. 9x squared subtracts nothing, so that remains the same. But if nothing subtracts a negative, subtracting a negative makes the sign change to positive. So nothing subtracting negative makes a positive x, and minus 5 is just coming along for the ride. Then go again. If x squared tries to divide into 9x squared, that's going to be a 9. I'm going to do a plus again. I'll always do a plus when the signs are the same. If we had a problem where these had different signs, I'd do a minus, but that hasn't happened yet on the board. So 9x squared, dividing x squared, that's what we just did. Divided the leaders, total cancellation, just leaves us 9. 9 multiplies everybody, so 9x squared, minus a 9, the minus 9 I'm going to line up with the like term friend, and then I'm going to subtract to get the remainder. That's just a speck on the board, not a negative. When these subtract, they're gone. When x subtracts nothing, it is unchanged. When this subtracts a negative, we're subtracting in our mind, we're thinking subtract. Subtract a negative makes a minus minus do plus kind of thing. This will end up being a plus 4. And then you have two choices. Do what the back of the book does. Some books will go remainder with the r and put x plus 4. Other books will do an add sign and make a fraction by putting that x plus 4 on top of the divisor. Same thing used to happen to you in this land. If we had this problem work to this point, sometimes you would put the r and do a 9. Sometimes you'd make a fraction by putting 9 over 21, which would reduce to be 3/7. But whether you're doing a fraction or the r, it's not important to me particularly, so I say just do what the book does, and we'll figure it out from there. So this is just, again, the same process as what we were doing over there. It's just here to reinforce it with a third practice problem, but there's nothing different about it. We want to always start off, as always, dividing the two leaders. If dividing those in your mind is troublesome, take 9y to the 4th out of the way. Take the other leader with 3y out of the way. But if you can divide that in your mind, 3 to 9 goes 3. And the difference on powers is y cubed. Then, as always, the top level thing we just created multiplies everybody. So 3 times 3 is 9. Powers of y up to 4. Multiply 2 by 3, that's 6. And that has y cubed. And then, as always, we subtract. The first items should always be perfect match and eliminate when you subtract. So perfect subtraction. When the empty spaces subtract things, it switches their signs. 0 is subtracting a positive 6, so that's negative 6, y to the 3rd. And when the top row drops, it never changes. Then we go again. If you can't do it in your mind, negative 6y 3rd can move over there. Bring the 3y again. As I said a couple minutes ago on that other problem, when a negative's dividing a positive, that's when we bring negatives into this. 6 dividing 3 is 2. The y differences are 2. So this negative 2y2 has to multiply everybody, which is negative 6y3 for that perfect match, minus 4y squared. when this multiplies both, we make those. When we subtract perfect matches, they vanish. Positive subtracts negative, so there's a minus minus make plus moment here. That's getting us up to 18y squared. Top row never changes when it drops. Now 18y squared is going to divide the 3y. If we divide those, that's a 6y. Positive when the signs are the same. 6y multiplies this for 18y squared. And 6y multiplies that for an add 12y. Subtracting the perfect matches eliminates them. When emptiness subtracts positive, that's negative 12y. Top row just keeps coming as it was, unchanged. If negative 8 subtracts an empty space, it's still a negative 8. Then the negative 12y from here is going to divide the positive 3y from there. Dividing those is just a negative 4, because the y's would eliminate. When negative 4 multiplies this, it's the negative 12y to always create that perfect first match. Negative 4 times positive 2 is negative 8 to create a perfect match there too. And this has no remainder, which is unlikely to happen very often. And again, what that means, if I was really committed to factoring, I could have factored this. It wouldn't have been the easiest factoring you've ever done, but it could be done. This could be factored. And then this would cancel one of the factors you would have made. And the other factors could turn into all this stuff. I think that's a bad way to do that problem. I think it would take you longer to factor, cancel one of the factors, and then FOIL the other factors back out to get this. That seems like a real pain in the neck. So I don't think I'd recommend that as a strategy, but it could be done. Homework where we are is 266. Homework 266 is working to 32, and we're skipping the 3s. So 1 day homework out, 266. 2 days of homework out would be a sheet that you already have in your possession. So the sheet is due in 2 days. 3 days from now, we would take a quiz that covers everything from chapter 6 so far, 6.1 up to 6.5. And that's it.